Hey, what's up, guys? So, welcome to this video where we are going to talk about design patterns. Okay, and the main design pattern that's going to be the focus of this video is going to the strategy pattern. So, you may ask yourself and me the question, what is a design pattern? Okay, so design patterns are basically solutions to common problems that are faced in software design. Okay, you can consider them like a blueprint that are used to make and design software applications. Okay, and common software applications that you see in the real world and digital services, they use design patterns to develop their applications in a scalable and error-free manner. And you just have to look around to see some real-world examples, and and there are many. So we have YouTube over here, which uses the observer pattern. So YouTube has this publisher subscriber model where a user can subscribe to a channel and consume their videos. So the observer pattern is used over here. And I think most of you have played PC games or computer games, mobile games, games in general. So games, they use a strategy pattern to design and develop their characters and their behaviors. Okay, the strategy pattern. Before we get straight into it, let's assume we are in a situation where we have to design software. Let's assume that the software is a computer game, to be specific, and let's say to be even more specific, let's say you have been given the task to design the characters of a game. And as a starting point, let's assume the characters are humans, and basically the game is a first person shooter, and there are actually a number of characters which have their own specific characteristic which distinguishes from them from others. Okay, so you can say that no two characters are the same. You know what? Let's call our game that we are building the Art of War. Okay, diving straight into it. Uh, this is an interesting pictographic model that you can probably understand what it means. Okay, so these are basically the characters that are gonna be there in the game. I think you already figured it out that our game is gonna be a military shooter, first person shooter based game. Okay, or a military simulation game. So we would have a base character or the base soldier from which we can derive more specific and special classes of soldiers. So we have the foot soldier or the infantryman. Then we might have an anti-tank soldier, the one who is responsible for dealing with armored vehicles. And then we have the sniper. And let's say we'll have the spec ops soldier as well. Okay, I think this basically gives us a basic idea of what the characters in our game are supposed to be. So I think you already know that each of these specific characters, they have their own roles, they have their own weapons. There is always something that differentiates them from the other, right? And if you look at the whole picture, you can see maybe you have already found a solution to develop this model. You may argue that we can use inheritance to develop this section. So we might have a base character which we can extend to make more specific characters, which their own uh, special characteristics. All right, then let's get more technical and understand this UML diagram. All right, So we have developed this UML diagram for the inheritance model that we have proposed for designing our characters. And to make things simple, we are gonna keep the behaviors and the attributes to a minimum. Let's say our soldier is gonna have a uniform that's gonna define which country he's from or which faction he is from. Let's say he's gonna have an integer health, which is gonna determine the health of the character in the game. Then, of course, since it's a soldier, he's supposed to have a weapon. Let's say he has a primary weapon and a secondary weapon, and we will have these specific classes of soldiers that's gonna inherit the base soldier class. Okay, and they are gonna have their own varieties or their own weapons that are specific to their use. So you got a foot soldier over here who's using, let's say, an M416 rifle. I think those of you who have played PUBG will know what this means. Then we'll have a sniper who has his own rifle. Then we have a spec ops guy who has his own variant, and an anti-tank guy who has his own variants. So basically, these guys inherit the behaviors of the base class. So the base class has behaviors like display the character, move the character, shoot the rifle character, and shoot the pistol behavior. Okay, shoot rifle behavior and the shoot pistol behavior. So obviously, the foot soldier is going to inherit the display and the move behaviors, and likewise, all the other characters are going to inherit the same behavior as well. You might argue that we can have our own version of the shoot rifle and shoot pistol behavior in these subclasses. Okay, you know what? Let's dive straight into coding it out. Okay, so I think you can see the IntelliJ ID that I have over here. So for our purpose, we are gonna use Java to code it out. So you can see that we already have the base player class implemented over here, and like we mentioned in the UML diagram, we have the health, we have the string name, we have the name of soldier, we have the uniform. This base player even has a rifle and a pistol. And we have defined, let's say, a constructor to initialize these member variables. And let's go ahead and look at the subclasses. So we have the foot soldier who extends the base player, and for the pistol he has an M1911, for the rifle he has an M416. So you can see over here very clearly that we have made customizations on the base player class to define how the super soldier would behave or what the foot soldier has. Okay. And if we come to the sniper class, you can see that he has his own variant of weapon which is different from the foot soldier class. Similarly for the pistol as well. And for the anti-tank guy, we have his own behavior as well. Okay, so coming back to the main class, let's construct our soldier and see how he behaves. Okay, we have made our foot soldier over here. Let's call him Jami and we give him a Canadian uniform. Okay, and calling, we are going to call the display method. We're going to shoot rifle method to make the player shoot his rifle. We're going to call the shoot pistol method to make the player shoot his pistol. Okay, then let's run this class and see what happens. Okay, it works. Now for now whatever we have done seems to be working perfectly. So our inheritance is doing the work of code reuse. It's enabling us to make customizations. So everything looks fine for now. But let's say we come across a situation where you are told to design a player which has a rifle but doesn't have a pistol. You get what I mean? So for example, let's say we have an anti-tank soldier. Okay, he extends the base player and we have initialized his name and his uniform and we have given him a rifle. But yeah, we haven't handed him a pistol because an anti-tank guy isn't supposed to have a pistol. He's supposed to carry a rocket launcher as a sidearm. Okay, then we don't need to have this method over here. Let's comment it out. Okay, coming back to the main class, uh, let's put our focus on the anti-tank soldier. Okay, so anti-tank soldier will have some weapon that he can employ to destroy tanks. He is supposed to have a rifle and a rocket launcher. He cannot carry a pistol though. So what do we do? Let's say we have created our object over here of the anti-tank soldier following our rules. Okay, anti-tank soldier, fine. Let's name him Timmy. Let's give him a Russian uniform. Okay, we call the display method, we call the shoot rifle method. This is expected, right? We expect this guy to shoot a rifle. But let's see what happens when we call the shoot pistol method. See, we get an error. So I think looking at this, you can probably point out what the issue over here is. So because of the inheritance model that we use to design our game, some behaviors are changing between the subclasses. And since we are inheriting those behaviors from the superclass, we are creating side effects that we don't want intentionally. So we don't want our anti-tank guy to shoot a pistol, but since this guy inherits from the base player, he is able to do so. And when we call this method, we are getting an error because he doesn't have the pistol in the first place. So this is one problem. Okay, and let's keep this problem aside and let's say we have a new requirement. Okay, what is the requirement, you ask me? Let's say we want our soldiers to have an armor that's going to protect him, or maybe make him able to take less damage than a person not having an armor would be able to. Okay, so you said what? Okay, so what should we do for this? uh, Maybe we can go back to our base player class and add that property over here. So I have already defined an armor class. Let's say we want our base player to have an armor. This seems simple. Okay, and let's implement a behavior use armor that's gonna make the player be able to use the armor that he has. Okay, so we can call armor dot use armor. So I have defined this method already in this class for our purpose. Now you may argue that our work is done over here. Now we can use armor behavior in any new class that we choose to create. Okay, fine. But what about the classes that we had declared before? Does the foot soldier have any armor? No. Does the sniper have any armor? Nope. Does the anti-tank guy have any armor? Nope as well. Let's say we want the foot soldier to have armor. Okay. So what can we do over here? Hmm, Okay. So as we discussed, let's say according to our new requirements, uh, the foot soldier can have armor. Okay. And what about the anti-tank guy? He isn't supposed to have armor. Cannot have. Hmm. So that leaves us with no option. I mean, basically, the only way we can make this work out is by making changes in the classes that we already created. Okay, so I think we'll have to override the method to not have that armor or basic. I think we have to override the method use armor over here. Okay, so instead of the superclass behavior, we want it to have our own behavior. Let's call it no armor here. And since we didn't want our anti-tank guy to shoot a pistol as well, we have to uncomment this class and implement our own behavior for the shoot pistol method. You might argue, yeah, this would make it work, right? We can have, and if we run a class over here, everything should work. It works. And since we already inherited the use armor method from our base class, we can call this method as well. Let's run our class again. See, it works. But I want you to think about this. The code base we have right now over here is very small. It's literally limited to like 4 or 5 classes. But what if we have a code base that has like 500 classes, maybe even 1,000 classes? Then in that case, I might argue that the way that we handled the changes over here by making changes in each and every subclass is not very scalable and actually very error prone. So you cannot go about making a change in every each of these 500 or 1,000 classes. You are gonna make some error here and there, and yeah, it's not very scalable to say the least. It's not at all scalable. So then you might think, what should we do? Like, we don't have any other option over here. In that case, I think the only thing that we can do is basically turn the pages of a design pattern book and look for a design pattern that solves our problem. So before we get to pick a design pattern that solves the problem, we have to know what the problem is. So our problem is that we have a base class. The base class has some properties and some behaviors, and the subclass inherits those properties and behaviors. But the problem is some of these properties are gonna be the same throughout the base classes, throughout the subclasses actually. And some of these properties can change, like this property. Some players might have a pistol, some of them might not have a pistol behavior. Some players might have an armor, some of them might not have an armor behavior. So these things are dynamic, they are changing. Okay, and to make it work, what did we do? We basically hard coded those behaviors. Let's go to the anti class. So we hard coded this, and we hard coded over here. This can actually lead to side effects. So as you can see, there are two problems over here. First of all, since we are hard coding behavior of the entities, and the behavior has a tendency to keep on changing between the subclasses, it can lead to unexpected side effects. As we saw in the example, where it can lead to an anti-tank soldier having the ability to shoot a pistol, which he was not actually intended to in the first place. And let's say we get new requirements, we have to add a new behavior, and adding a new behavior is very difficult. It can lead to unexpected side effects again, and we have to make changes in the subclasses to make sure that side effects don't occur. And this way of handling this problem is not very scalable at all, and it's actually very error prone. For example, if you want to have the player have an armor or a shield ability, so what do we do? Hmm. Then only one of the design patterns that's going to solve our problem over here comes to mind. It's called the strategy pattern. So the observation over here is that there are some behaviors that are not common among subclasses that can change and that are dynamic. So turning those behaviors instead of having those behaviors as functions in our base class, we turn them into interfaces having that functions. So what does it do? This basically gives us the ability to configure the behavior at compile time instead of hard coding the behavior. Okay, that's not very clear, you might argue. So you know what, let's dive straight into the code and see what it is. Okay, so now that we have identified our problem and know that the solution is gonna be by using the strategy pattern, let's identify the places or the attributes that are quite changing and quite dynamic. Okay, so let's argue that the health is gonna be constant among the subclasses. So all subclasses are gonna have a health field, all of them are gonna have a name field as well, and similarly all of them are gonna have a uniform. Maybe we can have them they can have the weapon behavior and the armor behavior that's going to keep changing among subclasses. And what are we doing for these attributes and properties? So basically we have methods that implement that behavior. So going back to our solution, it states that whenever we have changing behavior among subclasses which they inherit from the superclass, we are supposed to make these properties instead of functions to interfaces. So what does this exactly mean? So basically, instead of having these attributes, let's comment them out. We are going to define an interface that says I rifle behavior. Okay, so this interface is going to determine how our rifle behaves. Okay, and then let's have similarly the I pistol behavior. So this is going to determine how our pistol behaves in the subclasses. Similarly, last but not the least, let's have the eye armor behavior. Okay. So now what? Let's comment these methods out. So we want these interfaces that we defined over here to implement the methods that we have over here. Okay, so let's go ahead and create our interfaces. I'm going to create a new package over here and let's name it behaviors. Okay, let us create the eye rifle behavior over here. Let's turn it into an interface. We're going to import this class over here. Similarly, let's create our eye pistol behavior. It's going to be an interface, and we have to import it over here, of course. And last but not the least, let's create our eye armor behavior. Okay, so we have solved. I think we have a typo over here. Moment. Eye armor behavior. Okay, that should do it. So now coming back to our solution. So these methods that we have, rifle shoot, pistol shoot, use armor. Let's shift these methods inside these interfaces. So we want our eye armor behavior interface to implement a public use armor method. Let's make its return type as void for our purposes. Similarly, let's give our eye pistol behavior a public void method use pistol. And let's do the same over here. Public void. So I think we are kind of done over here. And instead of having methods like this, okay, let's change these to, so we want our player to be able to shoot a rifle, right? And he has this interface that's implementing that behavior. So what are we gonna do? Let's take our eye rifle behavior dot use rifle. That's it. And similarly, let's do it for the should pistol behavior dot use pistol. And let's remove this because we don't need it. Uh, Similarly, for use armor, let's have I armor behavior dot use armor. That's it. And since we don't need this over here, let's remove them. So to make it more clear, let's imagine we have a new soldier that we have to implement. Okay, let's call him custom soldier. Okay, I'm gonna create a class over here, custom soldier. Okay, and we want our custom soldier to extend the base class. That's the base player class. Okay, and let's create a constructor. That's it. Hmm. Now let's suppose our requirement is we want our custom soldier to just have a pistol and have an armor, but no rifle. Okay, so you might think that we are supposed to create some methods over here, and turns out we don't. You're just gonna leave it like this. And here's where the magic begins. Okay, mm, okay, let's to make it simple, let's turn all these variables to public type. Let's go back to our requirement. So we want a custom soldier. Okay, he has a pistol behavior. Doesn't have rifle behavior. Let's say, and he has armor behavior. Okay, so we have a blueprint over here, and what now you'll get to see how this design pattern is so amazing. You literally don't have to do any changes over here at all. No changes in the subclasses anywhere at all. No changes in the foot soldier class. Okay, yeah, this thing we have to change though. Since we are using interfaces to implement this, let's remove this. And let's remove this as well. Since I said we are not going to make any changes in the subclasses. So this is what the subclasses are limited to. That's it. They have a constructor, similarly over here as well, and over here as well. That's it. No changes in our subclasses at all. So now what do we do? So we want our custom soldier to have a pistol behavior. So let's create a class that implements our pistol behavior. Okay, so let's call it as uh, has pistol behavior. Now we wanted to implement this pistol behavior class. I mean pistol behavior interface actually. My bad. So we get an error over here now. It's very natural because we haven't implemented the methods that are defined in the interface. So we are gonna just click over here and there are our methods. Okay, so to have a pistol behavior, we need to have a pistol, right? So let's say we are defining a pistol inside this class, and let's say it's a pistol. That's it. Uh, Maybe we can give it a constructor to initialize that pistol. Just pistol equal to pistol. Okay. Now we have to use this method. So since we have a pistol inside this class, we're just gonna use it. Pistol.shoot. That's it. So we have implemented a has pistol behavior. So what about the soldiers who don't have a pistol? Okay, so we are gonna go ahead and do the same. Let's have a no pistol behavior. It's funny, I know. Let's have a no pistol behavior class. Maybe I could have thought of a better name over here, but let's keep it short for now. You know, implements I pistol behavior. Again, let's implement our methods. So since there is no pistol behavior, we don't have any pistol over here. So for use pistol, we have to override to something like no pistol over here. And going back to our custom soldier, he doesn't have a rifle, right? So we have to implement no rifle behavior for him. Okay, so let's do that as well. No rifle behavior. This this class is gonna implement the I rifle behavior, and again we have to implement those methods. Since no rifle, let's not have any rifle property inside here, and we are gonna just give this a placeholder method. No rifle here. Okay, now we come back to our custom soldier. He has to have an armor behavior. Okay, so for our purpose, let's create a armor behavior class. As armor, it's gonna implement my armor behavior. Okay, since this class is supposed to have an armor, let's give it armor property. Let's make it have a constructor. This dot armor equal to armor. We have to make our constructor public. Yep. Use armor. So basically, since we have armor over here, we're just gonna use it. Armor dot use armor. That's it. Okay, let's make our constructors public. Okay, that's it, I guess. Yep. So now what do we do? So we have all our custom behaviors defined, and we have our custom soldier as well. So if you notice, we have basically created new classes for new behaviors. We haven't made any changes in our subclasses at all. So that's very obvious. And you know what? Let's move these from here, here, and here, here, and here. Hmm. Let's test our design now. Okay. So what we can do over here, we're going to test everything one by one. Let's remove all this garbage and let's create our custom soldier. New custom soldier. Okay, we need to make it public. Done. Now we need to give him a name. Let's call him Augie. And as for this, what do we have to give him? We have to give him a uniform. Let's give him a new Russian uniform. Okay. But what about the behavior that we are going to implement for this soldier? So custom soldier dot eye armor behavior. So now you can notice over here what we can do. So we can basically dynamically change our behavior for this soldier. So we want our pistol behavior to be like new has pistol behavior. And let's give him a new. Which pistol should we give him? Let's give him a deagle. So we have given a pistol and let's define his eye rifle behavior. No, this guy isn't supposed to have a rifle, so let's give him a no rifle behavior. And that's it. So what else is he supposed to have? Yeah, he is supposed to have an armor behavior, right? Because he can use his armor. So let's make it equal to new has armor. Okay, and we want him to have. Okay, I think where is our armor? Has armor. What is there over here? Okay, we have to give this guy the armor, right? Because we have made the constructor like that. Yep, that's it. So if you notice what we have basically done over here, we are dynamically assigning behaviors to our soldier classes instead of hard coding it inside the class itself, the base class itself, the soldier base class and the soldier subclass itself. So if we go back and look at our custom soldier again, there is nothing over here. We didn't have to make any changes. If we go back to our anti-tank guy, we didn't have to make any changes over here as well. See, they're gonna work just fine. So let's test our code and see if it works. So we have created our soldier, and you know what? Let's call the necessary methods. Let's say we want to display our soldier, custom soldier dot shoot pistol. Okay, custom soldier dot shoot rifle, custom soldier dot use armor. See? Okay, so let's run this. There you go. Everything works like a charm. And you might argue, what about our old subclasses? We didn't make any changes to them, right? They should still work, right? You know what? Let's test it. we have our foot soldier. So base player, let's create a foot soldier. New foot soldier. We have to give him a name. Let's call him. What shall we call him? Benjamin. Okay. So our Benjamin guy is from America. So let's give him. I mean, he's from Canada. So let's give him a new Canadian uniform. Okay. So our base player is a foot soldier. So he's supposed to have a rifle, right? So let's give him a high rifle behavior. Do we have a has rifle behavior over here? No, right? Then we can create one just like that. So let's create our has rifle behavior. And what is this class gonna implement? It's gonna implement the high rifle behavior interface, right? High rifle behavior interface. Okay, hell yeah. So let's implement those methods. Okay, since we are implementing the has rifle behavior class, we are supposed to give it the weapon. Let's give him the rifle, and let's get a public constructor, public void has rifle. Void just behavior, and you're gonna pass him his rifle so that he can use it to shoot the bad guys. And let's initialize it over here. That's it. And since we're implementing this method, we can choose it to customize it in our own way. So maybe we can add something over here like what should we write over here? Something silly. Boom. That's it. And of course we're gonna call rifle dot shoot. That's it. So let's go back to our main class. See, we just created a new behavior without any changes. We just created a new one, and we can use it directly over here. Has rifle behavior. Which rifle do we want to give him? Let's give him a new M416. Good. And what else? Let's say we want to give him a pistol. Is pistol behavior. So we have to give him the new has pistol behavior. What pistol should we give? Let's give him an M1911. That should be fine for his requirements, I guess. So we want foot soldier dot. We want him to have an armor because we want our guy to be protected, right? Yeah, we want him to take less damage. So let's give him the his armor behavior as new has armor. Let's give him a new armor. I think we are done with creating our foot soldier over here, and we can call the same methods just to show that it works. Let's comment out our custom soldier. Oh, my bad. We'll have to change this to foot soldier. See. Let's run it. See, it works. Okay, so that's it, guys. That's gonna summarize our strategy pattern. Okay, so you can have a look over the final UML diagram over here. So Like I explained before, the way to describe strategy pattern is we just take out the behaviors that are changing between the subclasses and we simply turn them into interfaces. Okay, so let's say we have a behavior which defines the behavior of the pistol, and we have a behavior which defines the behavior of the rifle. Similarly, we have the behavior defining the armor behavior, and we simply turn them into interfaces which implement that behavior or that method. And depending on our requirements, we can just make classes that implement those interfaces, and they are gonna have the custom implementation of that method. So this gives us the flexibility to create the behavior in our own way. So ultimately, the subclasses is going to inherit the base class, which is going to have just the common behaviors or the common properties. That's it. And the things that are changing, like the pistol behavior, the rifle behavior, and the armor behavior, they are going to be interfaces. And the foot soldier can just have the required implementation of its choice. Okay, so let's just summarize the strategy pattern over here. So whenever we have face a problem where the requirements are constantly changing and we need to add new requirements, in that case we can always confine the behaviors and properties that are going to be common across all objects to inheritance, and behaviors that have a tendency to change should be implemented using interfaces. So that's it, guys. That's gonna wrap up the strategy pattern for us here today. Thank you, guys. See you in the next one.